Okay everyone, welcome back to another tutorial by the Flight Sensei, and today is going to be my first video. We're going to be talking about the four forces of flight that are acting on an airplane. Now, to get things started off, I'm going to actually use these drawings just like Khan Academy does. I'm going to show you guys where those four forces are acting, where they're acting through, and you guys will basically see how they're acting on an airplane, how they're interacting with an airplane, and what it means to be in a state of equilibrium and so forth. So this is basically, the introduction. It'll set the pace for the rest of the videos as well, and I think this would be just a great starter to start off with. So to start off first, what I'm going to do is I'm going to draw an airplane over here, and this is going to be my best attempt at drawing an airplane. It's going to be in the color burgundy over here. And we're going to get started over here. So here's my best attempt at drawing an airplane. So I got it going on like that, and so forth. Got my rudder over here, right, comes down across, okay, and finishes off right there. Okay, so let's pretend for a moment over here that this is my airplane, and over here I have my, let me fix that over here. So over here I got my airfoil as well. Okay, and again, I'll go into the the mechanics of the airfoil later on. Just for those who don't know, an airfoil is literally just a cross-sectional view of an airplane's wing, and that's all it really is. So I got an airplane over here now, and we'll basically start drawing our forces of flight. Now there's four forces of flight that are acting on an airplane at all times during flight, right? And those four forces, and if you're an aviation enthusiast like myself, those four forces are one, which is lift, right? And lift acts upwards, like so. So we got lift up here, okay? In red, I'm going to draw drag, right? Actually, hold on, let me just fix this. So lift is actually going to act a little farther back over here. So here's lift, right? From back here, all the way up. And this is my first video, so forgive my drawing skills. They're not the best, but they will improve hopefully. Okay, so we got lift over there. Now we got drag, weight actually, which is the other force. Weight is also known as gravity, and that acts downwards on the airplane. Okay, and this goes all the way straight down to the center of the earth. That's what gravity and weight basically mean. Okay, so you got lift, you got weight. There's two more forces we have to cover. Okay. The next one is called drag. Okay, and to best illustrate this, I'm gonna draw it from over here and draw it back. So there's drag. It's not my best drawing. Not my best drawing, but there's drag, okay? So drag is the force that is opposite to thrust, and thrust is the force that causes us to move forward. In other words, thrust is generated through the aircraft's engines, right? Drag is just the force that opposes the forward movement of the airplane, right? So we got our thrust over here, okay? Just like so. Okay? So thrust, again, movement forward. Drag is the reaction against movement forward, which is basically our movement forward is thrust in this case. We have lift, which acts a little farther back than weight over here. So lift actually acts through the center of pressure, and drag, weight acts through the center of gravity. And we'll get into that later on. So we got lift over here, weight, we got thrust, and now we got drag. Now, when an airplane is in unaccelerated flight, meaning that the airplane is neither accelerating nor decelerating, and it's not going up nor is it going down. It's stationary where it is, okay, at an imaginary point. Let's say it's in the sky. Then that airplane is said to be in equilibrium, okay? So I'll write it down over here for you guys, okay? So when it's unaccelerated, right, and I'll use the abbreviation U and A. Okay, so unaccelerated flight, okay, equals, we have ourselves equilibrium. And to write that out, I'll write down EQ. Okay, unaccelerated flight, right, we have equilibrium basically, okay? Now, when you're actually flying an airplane, that's not the case. That's not what's going to happen. So when you're actually flying an airplane, I'll find another color over here to use. Trying to find one that might work here. Let's use a slight red over here. Okay, so let's say now you're in actual accelerated flight. Okay, so I'm going to write down accelerated here as ACC. Okay, accelerated and then flight. Okay, so let's say you're actually flying the air. In this case, thrust over here will be greater than drag. So in accelerated flight, basically here's what's happening. Okay, we got thrust, which is in this yellow over here. Okay, thrust, okay, is greater than drag. And that's why we have our forward motion. And likewise, lift is greater than weight. Okay, so we got lift over here, and that is greater than our weight. We'll use a different, we'll use the weights color up here. So we gotta use an orange, so lift is greater than weight. Okay, and in this case now, what you have is accelerated flight. You have thrust, which is greater than drag. So basically the amount of thrust you're producing is greater than the number of drag that you have, and the lift is obviously greater than the amount of weight that you have. To illustrate this in numbers, in a numbers perspective, what we can say is that, let's say over here, if this is accelerated flight, right, you would have 2,000 pounds of thrust over here, 1,500 pounds of drag, so you have 500 pounds of net thrust being produced, and you're basically moving forward. Likewise, in unaccelerated flight, everything's going to be balanced out. So you're going to have 200, right, for thrust, right? You're going to have 200 for the drag, okay, and just like so. And let's say you have 500 each for lift and 500 for, drawing the 500 is kind of hard, but 500 for weight or gravity as well. So 500, just like so. Okay, now this is basically in unaccelerated flight. That's what's going on, right? If we wanted to show accelerated flight, this would change. So we would basically do instead here, add another 0. That's an awful 0 there. But if we add another 0 over here, okay, now we're at 2,000 pounds of thrust, 200 pounds of drag. Our net is 1,800 pounds of thrust, and we're going to be moving forward. Likewise, our lift, and these are not realistic numbers, guys. These are just as an example. Now we got 5,000 pounds of lift, 500 pounds of weight. We're obviously in accelerated flight now, and we're obviously moving up and forward. And so this basically, guys, constitutes the 4 forces of flight in flight. This is how they're interacting with one another. Again, when they are in a state of unaccelerated flight, then they are said to be in equilibrium. Just pay attention to that. But when it's in accelerated flight, that's when thrust is greater than drag and lift is greater than weight. Thanks guys for watching this video. I hope you guys liked it, and if it actually proved of benefit to you, then recommend any other videos that you might be interested in me going over, any other tutorials you might want me to explain to you guys. I have a lot planned out for this account as well, the Flight Sensei account. I'll be teaching meteorology, navigation, general knowledge on aviation as well, and maybe some other documentaries that I might make myself. Again guys, if you liked it, I hope you like this video. Subscribe if you're interested. If you want to find out more, definitely get in touch with me. You can contact me on Instagram as well. Let me know what you're wanting to learn, and then I'll try to do a video on that. Thanks guys, have a good day. Bye.